All right, so hopefully you've gone ahead and tried this assignment on your own, but now we're going to talk about it. So it starts out with this story about the tortoise and the hare. And the part that you're really interested in is this equation right here, which tells us that the distance of our tortoise at any given time follows this equation. So it starts out with this story about a tortoise named Shelley, and her family is coming to watch her run the race. First question, we want to know if the family wants to see her 10 seconds into the race, how far away should they stand? And if they want to see her 20 seconds into the race, how far away should they stand? So we're going to start with the 10 seconds. And notice that this seconds is our time, so it's going to go into the t spot of our equation. So we're going to say then that the distance is equal to 2 times the time, which is 10 seconds. If I type that into my calculator tells me it equals 1,024. So then I know that Shelley's family would need to stand 1,024 meters away from the start of the race in order to see her run. I'm going to let you go ahead and do that 20 seconds on your own. Question 2 says to describe the graph of d of t, or Shelley's distance at time t. And we want to know what are the important features. So to do that, I'm graphed this on my Desmos, which is right here. Okay, so we have that y equals 2 to the x. I'm going to use x instead of t. And that's just 2x. So 2 to the x. There we go. And this is the graph right here. And I'm looking at the graph and we want to know what we notice about it. So the first thing I notice is this shape is a swoopy shape. You might remember that that shape is called exponential. So I'm going to write down that it has an exponential shape. Okay, and then we're going to add anything else you can think of. For example, I notice looking at this graph that I have a y-intercept here at the point 0, 1. So I have a y-intercept at the point 0, 1. And I also notice that I have an asymptote. Remember that an asymptote is a line that the graph gets close to but doesn't cross. And if you look at this graph, I have this asymptote here on the x-axis. Oh, sorry, I'm trying to point it out, but it's not working. But I have this asymptote here on the x-axis. My graph gets close to the x-axis, but it never actually gets there or crosses the x-axis. So I'm going to write down that we have an asymptote on the line y equals 0. That's the x-axis. Now there are some other features, and if you thought of them and added them to this description, that's great, but I'm going to go ahead and leave it right there and move on. So question 3 says, if the tortoise family plans to watch the race at 64 meters away from Shelley's starting point, how long will they have to wait to see Shelley run past? Now please notice that this 64 is the distance. It's 64 meters. So remember how our equation was d equals 2 to the t, where d was the distance and t was the time. This time it's the distance that I know, that's 64 meters, and I'm looking for the time. So I'm going to say then that 64 has to equal 2 to the some time that I'm trying to figure out, and I'm not sure what that is. But you can go ahead and play around with your calculator. For example, I know that 2 to the first power is 2. I know that 2 to the second power is 4, so it's got to be more than 2 seconds. 2 to the third power is 8, so it has to be more than 3 seconds. And I'm just going to go ahead and continue that table down until I find the answer I'm looking for, which is 64. And I'm going to let you go ahead and finish that table on your own to find that answer. Okay, the next question, how long must they wait to see Shelley run by if they stand 1,024 meters away from her starting point? So again, notice that this 1,024 is our distance, and we're trying to find the time. So I'm going to say, okay then, 1,024 has to equal 2 to the sum time that I'm trying to find. And again, I'm going to let you go ahead and figure out what that number is. All right, now remember how we were working with this equation, y equals 2 to the x, or as it was written on this equation paper, d equals 2 to the t, which is the same thing. So here on question 5, I've been asked to graph it. So I'm going to start by drawing in my x and y axes. So I'm going to go ahead and put my x-axis right here on this line. Okay, there's my x-axis. And I'm going to put my y-axis right here on this line. Okay, so there's my y-axis. And when I make my scale, I'm going to count by 0.5. So I'm going to have 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5, 5, and so on. I'm going to do the same thing here on my y-axis. So I have 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4, and so on. Now, I've been asked to draw the graph, so I'm going to go ahead and graph this equation that they have given me, this y equals 2 to the x. So I'm going to make my table. And on my x-axis, remember we're measuring time down here on the x-axis, and that time is being measured in seconds. On the y-axis, we're measuring the distance that Shelly the tortoise has run, and we're measuring that, remember, in meters. So x is my time and y is going to be my distance in meters. So I'm going to go ahead and choose my x values. Let's do 0, 1, 2, 3, and 4. And then to get the y values, I'm going to plug into this equation right here. So if I have 2 to the 0 power, that equals 1. So my first y value will be 1. 2 to the first power equals 2. So my next y value is 2. 2 to the second power equals 4. So my next value will be 4. And 2 to the third power is 8. So I'm going to fill in my 8. And I'm going to let you go ahead and finish that table. But let's graph these points that we've already found. So I have the point 0, 1, which is going to be this point right here. Next up I have the point 1, 2. So here's 1, 2. It looks like is going to be right about there. I have the point 2, 4. So that's going to be 1, 2, 3, 4 right here. And I have the point 3, 8. So if that was 4, 5, 6, 7, 8 will land here. And you can continue this graph, but I'm going to go ahead and connect the dots that we have to give me this exponential shape. Remember that we already got when we graphed this earlier on Desmos. Number 6 asks how long the family has to wait to see Shelly run by if they're standing 220 meters away from her starting point. So since 220 is a distance, that's going to go into my D spot. So this becomes 220 equals 2 to the sum power that I need to find. Now, just like before when I was just guessing at powers, I can guess at powers here, but I know, because I typed it into my calculator, that 2 to the 7th power is 128, which is smaller than 220, but 2 to the 8th power is 256, which is larger than 220. So then I know that my power will have to be a number in between 7 and 8. So I'm going to go ahead with my calculator, just try out different decimals that are between 7 and 8 until I find the decimal I want. And if you've already done this, you hopefully found out that t is equal to approximately 7.78 seconds. Okay? Now number 7 is asking what the relationship is between our d of t and the graph that we have just drawn. So d of t, remember, is our distance, which we measured here on the y-axis. So I'm going to write down that distance is being measured on the y-axis. Now, there are some other aspects of this relationship, which if you thought of them and wrote them down, that's great, but I'm going to go ahead and leave it right there. Let's go ahead and move on to our next page. Problem 8 asks us to once again look at this function, f of x equals 2 to the x, and it asks us for our domain and range. Remember that domain is our x values, and that range is our y values. So for our domain, if we look back at that graph we just drew, our x values, if we go to the left, notice how this graph goes forever to the left. It's never going to stop going left. And it actually also is going to continue going to the right forever as well because it goes up, but notice how it also very slowly is heading to the right. So my domain then is going to go from negative infinity until positive infinity. The range is our y values, our up and down values. And if we look back at this graph that we were using a moment ago, if you look up and down, notice that heading down, well, the lowest down I ever go is this x-axis. I never actually touch it or cross it, and I definitely never get lower than that x-axis. We call that x-axis an asymptote. Remember, an asymptote is a line that the graph gets close to but never touches or crosses. So because we never touch or cross that, we're never going to get lower than 0. So my range starts at 0. And I'm going to use a parenthesis on that 0 to show that I don't actually get to 0, I just get really close. Now heading up on my y values, notice how this graph will continue going up forever. So my range goes up to positive infinity. So here's my domain and range. My second question is f of x invertible? And the answer to that is yes, it is. And in fact, we're going to be graphing that inverse here in just a moment. So question B says to graph f of x and f inverse x on the grid below. So I'm going to go ahead and draw in, just like I did before, my x and y axes. So there's the y-axis, and there's the x-axis. Okay, and remember I was counting by 0.5, so we have our 0.5, 1, 1.5, 2, 2.5, 3, and on our y-axis we had 0.5, 1, 1.5, 2, 2.53. Okay, and remember that this x-axis represented our time, and the y-axis represented our distance. Now, before we had this table that we had created, I'm going to do that in a different color. Okay, so our f inverse function, our original function, remember we were graphing the line y equals 2 to the x. And to do that, we had created this table that looked like this. I just copied that from up above. So if I graph those points, 0, 1 is right here. 1, 2 is right here. 2, 4, that's 1, 2, 3, and 4. And then 3, 8, 4, 4.5, 5, 5.5, 6, 6.5, 7, 7.5, 8 is right here. Okay, so here in red, I have graphed my original function. Now I'm going to go ahead and graph the inverse. Now remember last week we learned that to find an inverse, all you have to do is switch the x and y. So over here, I'm going to go ahead and take that same table, but just switch the x and y. So I get the 0.10, 2, 1, 4, 8, 4, 2, I'm getting ahead of myself here, and 8, 3. So if I graph these points, I have the 0.10, which is right here, 2, 1 is right here, 4, 2 is going to be right here, and then 8 counting, 8, 3, 1.5, 0.51, 1.52, 2.53 is going to be right there. Can I get this graph right here? It looks sort of like that. All right, so next it asks what are the domain and range of our inverse function. So domain, remember, is our x values, and this time if you look at the x values, notice how this time we have our asymptote here on the y-axis. My graph gets close to that y-axis but never touches or crosses it. So the lowest x value my graph will ever get to here is 0. And the biggest x value it gets to, well, it's going to keep going right forever, so it goes to positive infinity for my domain. Now range, which remember is the y values, those are our up and down values. So if I'm looking at up and down values, well, heading up, this graph is going to keep going up forever and ever. Oh, excuse me, we should have started down. Heading down, can you see how the graph will go down forever and ever, so it goes to negative infinity. And heading up, we talked about a moment ago, goes to positive infinity, because it will keep going up and down forever. Now, the important thing I want you to notice here is that the domain and range here of my original function and the domain and range here of my inverse function have just switched places. Domain became range, range became domain. That happens because it's an inverse. In an inverse, we switch the x and the y, which means the domain, the x values, and the range, the y values, will also switch places. Okay, last but not least, these last three questions. Number 9 says, if f of 3 equals 8, what is f inverse of 8? Well, remember that to find an inverse, all we do is switch the x and y. So here we're saying the x value is 3 and the y value is 8. Well, now for our inverse function, our x value has become 8, which means my y value has just switched and become 3. Based on that information, I think that you can go ahead and do number 10. And if you look at here at number 11, well, if f of a equals b, what is f inverse of b? Remember that a is the x value and b is the y value. Well, in our inverse, b has become the x value. So what's that y value going to be? If you said that it's a, you're correct. And that happens because when we switch, or when we find an inverse, we switch the x and y. Okay, and that is our entire assignment. Thank you for watching.